Greetings, my name is Amber Kean and I will be teaching you how to integrate. There are many different ways in which to integrate a function. Today I will be explaining how to integrate by using U substitution, inverse trig functions, integration by parts, trig integrals, and partial fractions. To begin, the first and most simple method of integration is U substitution. You should use this method before trying any other method because of its simplicity. It is a method for finding antiderivatives. The method of U substitution is a method for algebraically simplifying the form of a function so that its antiderivative can easily be recognized. This method is intimately related to the chain rule for differentiation. First, you find your U, which is usually a function raised to a power. Then you would find the derivative of your U, which is also known as du. Then plug U and du back into the integral and integrate accordingly. To integrate by using inverse trig function, you must first know how to identify them. When you see 1 over the square root of 1 minus x squared, you automatically know to associate it with the inverse of sine x. When you see 1 over 1 plus x squared, you associate that with inverse of tan x. And when you see 1 over the absolute value of x times the square root of x squared minus 1, it is the integral of inverse secant x. Integration by parts is used when two functions are being multiplied by one another. It is associated with the product rule from Calculus 1. The formula for using integration by parts is u times v minus the integral of v times du. To determine u and v, we use the acronym LIATE to help us determine what type of function to set u and v as. The acronym stands for L, logarithmic, I, inverse trig, A, algebraic, T, trig, and E, exponential. Once you find u, you derive to find du. And once you find dv, you integrate to find v and plug this back into the function stated before. Moving on to trig intervals. This is used when there are multiple powers of trig functions. For example, the integral of sine cubed x times cosine squared x. What you would do is you would separate the function up in a way that is easier to find a u and a du, which can easily be integrated. In this case, you will rewrite the integral as sine squared x times cosine squared x times sine x dx. Sometimes to integrate by trig integrals, you must use some Pythagorean identities, such as sine squared x plus cosine squared x equals 1, tan squared x plus 1 equals secant squared x, cotangent squared x plus 1 equals cosecant squared x, sine squared x equals 1 minus cosine 2x over 2, cosine x squared equals 1 plus cosine 2x over 2, and sine 2x equals 2 cosine x times sine x. For this example, I would make my sine squared x into 1 minus cosine squared x. I would then make my u cosine x, and my du would then be negative sine x dx. Then I would plug my u back into my integral and my du in and integrate normally. Trig is used a lot in Calculus 2, so our next method of integrating would be trig substitution. If you see a squared plus x squared, we know that that is a tan theta. If you see a squared minus x squared, then we would know that that is a sine theta. If we see x squared minus a squared, we know that is a secant theta. There are 3 simple steps to figuring out how to integrate using this method. Once we recognize the identities, we find the x for that identity, and then we find the dx. And lastly, we manipulate the radical. When doing these 3 steps, we use theta as our variable, but to convert back to x, we must use a right triangle. The last method I will discuss is integrating by partial fractions. We use this method when dividing by polynomials. Partial fractions can only be done if the degree of the numerator is strictly less than the degree of the denominator. That is important to remember. So once we've determined the partial fractions can be done, we factor the denominator as completely as possible. Then for each factor in the denominator, we can set up a workable function. The numerator that is set up must be 1 degree less than the denominator. For example, if I have the equation x squared minus 1, the numerator would be ax plus b. Or if the denominator were x plus 4, the numerator would just be a. After all the factored equations are set up properly, there are several methods for determining the coefficients of each term. It is most easily done by making one of the equations equal to 0. That is all for today. I hope you learned a lot and have a great day.